Okay, welcome to this lecture number 16, again on space geometry. Now, what we have done so far in our last two lectures in space geometry, we'll go through that. We looked into the line classification in our last lecture, and we are classifying a line, as horizontal frontal, provided the line was parallel to the horizontal plane and the frontal plane. Okay, so that kind of line we are saying horizontal frontal, or maybe a profile line. A profile line is a line which is parallel to the profile but is inclined to the frontal and to the horizontal. Similarly, the other classifications. And finally, the oblique line, which is not parallel to any of the principal planes. After this, what we did, here is an oblique line, and we understand that this oblique line in all three principal planes, it is coming at 4 short end, and we wanted to determine the true length of this line, okay, or the true projection, normal view of this. How to do it? To do that, we looked into a method, and the method is, I will very quickly give you an idea of the method very quickly. And using that particular approach, we are able to identify the normal view and the point view of the line. So what was the approach there? The approach was, we were identifying three planes, A1, A2, A3. A1, A2 are orthogonal, A2, A3 are orthogonal, and A3 is the final auxiliary plane where we want to make the true view of the inclined line, of the oblique line. On A2, we know the projection of the line. Using that A2, we are drawing the projectors, and we are taking the distances from A1 and then applying those distances in A3. That is how we will be able to generate the true length or the normal view of the line. In the second method, which is the method of rotation, what we do in this case, the line which is available on certain view, for example, there is a line and this line has a projection here, so this is the projection and that's the line. So this projection is on the horizontal plane. We rotate this projection. The meaning of this line is also being rotated. So we rotate this projection and make it parallel to the frontal plane. Once we do it, the line will become parallel to the frontal plane, and the projection of the line on the frontal plane will be normal view or the true view with the true length. So this is the approach. Here, this is the projection of the line on the horizontal plane. We are rotating it so that it is parallel to the frontal plane, and B has now shifted here to B dash F. Okay, so we are holding the end A and rotating the end B. So here also in the frontal, the B end will change its position, but because the rotation is happening only in the horizontal, okay, we are not giving any vertical rotation. Because of that, the end B will only oscillate or will be somewhere along this line only, and that is how we could locate B dash F. We know AF, so this projection is now the true projection or the true length. So this is what we have seen. Now, the important concept that we discuss in this, I will quickly go through it. We have a line, we have the front view of the line or the frontal plane, we have the horizontal plane, we have the profile plane. Okay, this line is projected on the frontal, also it is projected on the horizontal. So these are the projections. None of those projections are true projection, or rather the normal projections. So we need another plane, corresponding to this, we need another plane which is parallel to this line, and we call it auxiliary plane. So this plane is parallel to this, and with the help of the edge view of the plane, so the condition was the edge view of a plane, if it is parallel to the projection of this line onto the horizontal, okay, then this auxiliary plane will have projection of the line which will be normal. We have seen it. So using this concept, we are identifying the auxiliary plane. So that's the auxiliary plane here, and Once it has been identified, the projection on the auxiliary plane will be the true length or the normal view. Okay, then we also saw where this, how much below the ends of the line will be located, and we know it. We are making use of the distances in frontal here, or we can say A1. So this one we say as A1, here it is A2, and there it is A3. I will write it also in a while. So with the help of this, we are able to generate the projection. So this is how the projection of the line is done. So the basic rules over here, number one, we want to determine the, or rather we want to identify the A3 where the line can be projected, okay, the auxiliary plane. To do that, we first locate A2 where from the projectors can be drawn, okay, A2. In the above figure, it is the horizontal plane. Then we need where from we can measure the distances, okay. So the distances we are taking from A1, and here in this picture from the frontal. Alright, so this concept is useful and we'll be using it in future classes also, or in our other discussions also. So let us discuss now about the planes. Like for the lines we have some discussion, some classification, same thing for the plane. Of course the definition of the plane, we know it, can be done by 3 points, or can be defined by 1 point and 1 line, or maybe 2 parallel lines or 2 intersecting lines. Okay, they can define a plane. So somewhere in our space geometry, with the help of these definitions, we'll be identifying something called a plane. Okay. Then in addition to this, a plane we consider to be of infinite size, yes, and we can determine the orientation of the plane if we know its projections. We will see it. Finally, for a plane, there will be a strike and dip. What is it? The strike and dip. A very simple example we'll see. Look at this example here. So here is a sloping surface, like the rock which you can see over there. There is a sloping surface, and if this sloping surface is cut by a horizontal plane, all right. So the line of intersection, you can see the line of intersection going like this. This line of intersection is called the strike. And the angle from the horizontal plane to the plane of the rock, this angle is called the angle of dip. So over here in this figure, you can notice is, so this line, red line, is the strike, while the dip angle is the angle between, you know, the horizontal and this. So that is the angle of dip. Okay, and what is this line? This line is the direction in which if I drop water onto this rock, where the water will flow. Okay, that's the steepest gradient direction on the rock. So that direction, and then horizontal one, the angle is dip. So these are the terms we might use. So that's why I'm giving you these terms. Now something on the classification of the planes. First classification we are talking about is a horizontal plane. The meaning of this is a plane, let's understand this, a plane which is parallel to the horizontal plane. So if this is the case, what will happen? This plane will have normal projection onto the horizontal plane, while on the frontal it will have the S view. Also on the profile it will have the S view. Let us see this plane. So because we know for this plane that it is only known as normal projection in the horizontal, so we'll start from there. So they are the hinge lines. Let this is the plane and this is the normal plane. That's why I'm writing N over here. Okay, and these are the vertices. So the projection right now on the horizontal plane is the normal view of the plane. Let us draw for this the edge views in the frontal and in the profile, because we know the projection of this plane, because it is parallel to the horizontal, will be edge view on the frontal and also edge view on the profile. So if I do it for the horizontal, I can do it this way. Again, as we had done earlier, I have a choice. You know, right now I am making this projection over here. I have a choice. I could have done this bring these projectors down, I could have shown it here. AF, BF and CF. Okay, once the projection, the edge view is fixed in frontal, on the profile now it is fixed. So I don't have that flexibility of choosing it where I keep it. So on the profile now it will be fixed. So we will do it now for profile. So to do it for the profile, yes, again we'll make use of the meter line and the projectors. So what you notice, the A point and A point here, they are aligned as per the projector between the horizontal and the frontal. And now from the A edge, the projector is going to the meter line and then it is going downwards. So somewhere along this will be the point AP. Now where will that point AP be? From A, if I take the projector here, the point of intersection will be AP. So let us do it. So if I do this projection completed, so we have the AP, BP and CP. So we have edge view and the normal view, and this plane is horizontal plane. Alright, let's go for the next. The plane is now frontal, similar to the previous one. Frontal means it is parallel to the front, okay, parallel to the frontal plane. So its edge view will be seen in the horizontal and edge view will be seen in the profile. Let's quickly go through it, the hinge lines. So we will be making the normal view on the frontal plane, and now with the help of this I can generate an edge view on the horizontal. Once it has been done on the horizontal with the help of meter line and the projectors, I can also do it on the profile. So we have got the edge view and the normal view. So the plane is frontal in this case. Now some more definition, and now the plane is profile. So the plane is now parallel to this is my profile principal plane, and the plane is parallel to this. So the projection will be normal on the profile plane or profile principal plane, okay, while I will have the edge view because I am seeing the edge on the frontal and edge view on the horizontal. So let us do it. Alright, so on the profile I have a normal view of the plane, the true view of the plane. Using this I am now drawing the edge view of this on the frontal. I could have done it also on the profile, okay, from the profile I could have on the horizontal, and then I could have generated the view there. Anyway, I am doing it on frontal. Now once it has been fixed in the frontal here, with the help of the meter line I will be now drawing the projector from the profile and then from the frontal, and finally generating the edge view in the horizontal. Alright, so this plane is profile plane as its name. Okay, we may have the planes which are inclined to horizontal and profile and perpendicular to the frontal. So what kind of plane it is? Look at this plane. So this plane, if I rotate it this way, so this plane is inclined to profile. You can see the acute angle here. Also it is inclined to the horizontal. So that's the plane. But this plane is perpendicular to the frontal. So on the frontal I will see an edge view, while on the profile and on the horizontal plane I will see the foreshortened or distorted view of this plane. Let us do it, and we'll start in this case because we know the edge view. So using the edge view we'll start. So let's first draw the edge view of the plane on the frontal. Alright, so if this is the edge view, and on that edge view I am locating anywhere 3 points A, B, C, and writing them as AF, BF and CF. Now with the help of this I draw the projectors to the profile. Again I can have the plane anywhere. I can choose a plane like this. Further, if I extend, I can have a plane like this. I can have a plane like this. So right now it is my choice, and as per the plane that I select, and with the help of the meter line I will be then finally drawing the foreshortened plane or the view on the horizontal. So let's do it. Let I take this as the foreshortened projection of the plane for which I am seeing the S view on the frontal on the profile. Now rest is simple. We are making use of the meter line and the projectors and then drawing the projection on the horizontal plane. So this is foreshortened or distorted, while on the frontal we have the S view of the plane. Okay. We will use the same technique for a plane. The plane is being defined as perpendicular to the horizontal. Okay. So the plane is inclined to the frontal and profile. So it is perpendicular to the horizontal. So what kind of plane it is? The plane is inclined in this manner. So it is, that's the plane. I see the S view on the top view or the front horizontal, while on the profile I have a foreshortened view. On the frontal also I have a foreshortened view. Let us see this plane. So these are the hinge line and an S view of it on the horizontal plane. And AH, BS, CS I have chosen anywhere. Okay. Taking the projectors to the frontal and locating any 3 points, I will have now AF, BF and CF. Once it is fixed in frontal, now the projection on profile will be fixed. So to generate the projection on the profile, I will be taking the projectors from frontal to the profile and also from the horizontal with the help of the meter line to the profile, and where they intersect I will have the plane projection there. So let us do this and I join them. So look at this. So corresponding to point A, that's the projector. Similarly corresponding to point A here, that's the projector, and this is where they intersect. That's why we are locating the point AB. So here in this case, on profile and on frontal we have the foreshortened view of the plane, or rather distorted view of the plane, while on the horizontal we have the H view. Now we take it further. Now we have a plane which is perpendicular to the profile. The same thing. Okay, now the plane is perpendicular to the profile, but it is inclined to horizontal and to frontal. Okay, for these it is inclined. So using the same technique we can quickly start with the S view. So because the plane is perpendicular to the profile, so on the profile we will see the S view. Now from the profile, with the help of that we are drawing the projectors and then creating the projection on frontal. Now with the help of frontal and profile we will be creating the projection on the horizontal. So this is what the projected plane on the horizontal looks like. Again, on the horizontal and on the frontal plane, the projection of the plane is foreshortened, while on the profile it is S view, because the plane was perpendicular. It is perpendicular to the profile view. That's why we are seeing only the S view of it. Okay, there can be also the condition when the plane can be, say, inclined or oblique. We call it oblique plane. It is not parallel to any of the planes. It is inclined to all the planes. So how to identify that?